my friend. Look at my house. I have decorated my Christmas tree.
Wow, it is a nice Christmas tree. But why Kai Wei look so worried?
Christmas is really coming soon. But I'm not sure what are the presents to give for my friend.
Don't worry. Why don't we go searching online?
Oh, I found an interesting video about casing-based bioplastic. Let's watch it together.
Sure.
Hi! So today the experiment that we are going to make is turning the milk into casing plastic. So first we need a white vinegar, a full cream milk, a food coloring, whatever color that you like, a kitchen towel, a weight balance, a hair dryer, a tablespoon and a teaspoon, a big bowl, and a stove. So let's proceed to our experiment now. Let's go! The first step of this experiment is an approximately of 250 ml of milk is measured using a weight balance. The second step is we heat up the milk by using the pan and the stove. Thirdly, 4 teaspoons of white vinegar are added into a clean big bowl. Fourthly, the hot milk is poured into the bowl containing the white vinegar. Then a white curd will be observed. Then the mixture is stirred slowly with a spoon for a few seconds. After the mixture is cooled, 4 pieces of paper towel is placed to separate out the curds from the mixture. Afterwards, the curds are collected as much as they are formed by using a spoon and placed on top of the paper towels that have been set. Then the sides of the paper towels are bent over the curds and press it down to soak up the excess unwanted liquid from the curds. After all of the dry curds are kneaded together in a bowl of dough, the casing plastic is made. So to make sure it more appealing, food coloring is added during the process of making the plastic dough. Lastly, the casing plastic is set to dry on paper towels, and the hair dryer is used to speed up the drying process. And you're done!
Why the milk is heated before added in acid?
Let me explain it to you. The reason why the milk needed to heat before adding the acid is when heating the milk, where both casein and whey proteins are present. Whey proteins interact with the caseins cells to form the caseins whey protein complex. The disulfide interchange reactions happens and it leads to the formation of intermolecular disulfide bonds, which play an important role in the heat-induced engagements of beta-lactoproteins and have the interactions with the caseins. For the non-covalent interactions, such as the hydrophobic or ionic interactions, are also involved in the heat-induced interactions of the milk proteins. And this is a diagram shows when the milk proteins is undergo the heat treatment.
Oh, I see. Why the casein will precipitate when acid is added?
This is because the casein is the main protein in the milk and it is the phosphoprotein, which means that the phosphate group are attached to the hydroxyl group for some of the amino acid side chain, and the casein exists in the milk as the calcium salt, which is calcium caseinate. And the pH of the milk is about 6.6. Therefore, the casein is negative charged at this pH and is solubilized as a salt. And the calcium caseinate have the isoelectric point of pH 4.6. Therefore, it is insoluble in solutions of pH less than 4.6. When acid is added to milk, the negative charge on the outer surface of the casein micelles are utilized, and the neutral proteins precipitate with the calcium ion remain in the solution. And this is the equations involved. And the reason why the curds become solid and hard is because the casein react with the acid will form a long chain of the casein, which is known as the polymer. The reaction is coded as the condensation polymerization reaction.
Whoa, sounds like interesting. How about the mechanism of the reaction?
Allow me to explain the chemical mechanism. Generally, a K-casein chain has only 2 cysteine sites, whereby they can form an intramolecular disulfide bond. Heating exposes these sites. The K-casein will form disulfide bond with nearby denatured beta-lactoglobulin to form beta-lactoglobulin casein micelle complex. During the addition of acid, there are 2 steps of mechanism. 2 components involved are calcium caseinate and casein. This is the structure of casein micelle. Step 1 involves protonation of phosphate group. Calcium caseinate will react with hydrogen ions to form neutralized proteins and calcium ions, whereby step 2 is formation of casein polymer. 2 molecules of neutralized proteins will react and undergo condensation polymerization to form casein polymer, which is the curds and water molecules.
That's clear explanation from both of you.
But how does the coloring form?
Coloring are formed due to the absorption of visible light by the compound. With the presence of subsequence, chromophore absorb visible light, but the autochrome shift the absorption of these chromogenes into visible reagent. For example, in the experiment, tartazine is used. Tartazine is one of the dye compound manufactured by coupling of sulfonic acid with ethyl ester. The polar side of the tartazine will interact with amine group, amide group, and carboxyl group of the casein polymer to form protein dye complex. Hydroxyl group may form hydrogen bond with the dye.
Oh, now I realize that.
Both of you give me a great idea. I will try this out and send picture to both of you.
Sure.
Okay, bye.
Thank you. Merry Christmas, everyone.
You're done!